Okay, so in homework 3, the skill is looking at these numbers and trying to find some factors that are squares or cubes or powers of 7 in one question. And we're using the property that if we have the square root of two numbers multiplied together, so if we can find a factor that's the same as the root, we can split it up by saying it's the square root of A times by the square root of B. So we're going to be using this property throughout this exercise. So for square root of 44, I think we can spot that the square number that goes into this is 4. So 4 times 11. And splitting this up, root 4 would be 2 times root 11. So you see how we're using that property. Great, okay, so let's use the same thing in part B. These ones are a little bit harder to spot, but we want the square number we want in the numerator is 36. So 36, and multiply that by 3 and you'll get 108. 147 is very close to 50, which is very close to 49, and so it's 3 lots of 49. Doesn't matter which order we write these, by the way. So when we take the square root of both of these, then we see we're going to get square root of 36 is 6 times by root 3 in the numerator. Square root of 49 is 7 multiplied by root 3. Same number in the numerator and denominator, multiplying, we can cancel, and so we just get 6 sevenths, or 6 over 7. In part C, now we're looking for a cube number. So the cube numbers, well, what do we got? 1 cubed is 1, 2 cubed is 8, yep, that goes into 40. So 8 times by 5 is 40. Whoops. Sorry about that. If we've got the cube root of all of these. Also, this property also works with cube roots, don't forget. When we take the cube root of A times B, that's also the cube root of A times by the cube root of B. So here we'll do the same thing, and this is going to be equal to the cube root of 8 is 2 times by just the cube root of 5. And that has been simplified. So it's the same method here, just with a different degree. And indeed we've got an even higher degree, 7. So we should be looking at 256 and saying, well, we know that 2 to the power of 7 is 128. So maybe we can use that to help us here. So if we simplify this, we've got 256 is double 128. And if that's in the 7th root here, we can simplify this by saying it's the 7th root of 2 times 2 to the power of 7, remembering that if the degree is the same as the radical is the same as the exponent, cancels out. So these parts here will cancel out, and we'll just have 2 and multiply that by the 7th root of 2. Great. Okay, so in part E, we should realise that the degree of the root is also can be considered the denominator of the exponent. For example, if we go back up the top in a different colour perhaps, if we have m power of root a to the power of n, we've learned that this simplifies as an exponent to a to the power of n over m. So we can use this property here. So this will simplify, I should say, to x to the power of 9 over 3, which is just 3, times y to the power of 11 divided by 3, times z to the power of 19 divided by 3. So they don't work quite as well as 9, but we can simplify these powers into mixed numbers. So we've got x cubed. As a mixed number, this will be y to the power of, well, what's that? It's 3 goes 3 times, plus another 2 times, so 2/3 here, as a mixed number. Times by z, well, this is about 6, with another third remaining. So we're now we can factorise out the parts here that have an integer value here, so like x cubed, y cubed, z to the power of 6, and we can rewrite the fractional index back as a radical. So inside the radical here, which has a degree of 3, as we can see from the 3's in the denominator, then inside we just have y squared times by z to the power of 1, which is just z. So just looking back very quickly, we can treat these as exponents, treat the degrees as exponents, play around with them a little bit, and put them back when we factor out the integer values. The denominators here we can rewrite back as the degree of the radical. Alright, so for part F, we've got, we can't actually factor 6 to divide by a square number, but what is good about this question is we have the same radical term, and if we have groups of the same number, these are called like terms, and we can group them together. So if we have -3, -5, well, that's -8 lots of root 6, and that's as far as we can go with that one. So we can collect these as like terms if there's the same value inside the same root. Alright, so let's look at G. We'll go ahead here. 128. Alright, so we're back to square numbers. 64 goes into 128, multiplied by 2. And 98, 49 goes into 98, times by 2. Taking the square root and adding them together. Simplifying this, we'd get 8 root 2 plus 7 root 2. And using that same idea, we can combine these together to get 15 lots of root 2. Okay, so in 8, we've got square roots, so I think we can see that 8 can be 4 times 2, so 3 times all of that, and 18, what can that be? 9 times 2 in square roots. Beautiful. So simplifying this, we've got 3 times square root of 4 is 2 root 2, minus 4 times square root of 9 is 3 and the root 2. So simplifying these, 3 times 2 gives us 6 root 2, and that's minus 12 root 2. Grouping these together gives us minus 6 root 2. Alright, doing really well now. Last one, so we've got, we want a square number that goes into 27, you guessed it, 9. So 9 times 3, 20, I think we can have 4 times 5. For 147, that's similar up here in B, so that was 3 times 49. And they can't do much with 5. Let's just leave that one as it is, 3 root 5. Alright, so simplifying, we have 3 root 3 minus 2 root 5 plus 7 root 3 plus 3 root 5. Now, we can group together the ones that have the same inside part for the square root as like terms, here and here. So let's do the root 3s. How many lots of root 3? We've got 10 root 3. And for root 5, we should have just 1. And there we are. So we've had a lot of practice here at spotting different square numbers, cube numbers, and then also we looked at the idea of like terms with the same value inside the square root. Well done. We'll see you in another video.